Okay, so looking at the first three problems, we're asked to find dy dx. So that means that we are looking for the derivative, okay? So in this case, we are going to look at the ln and remember. So if we have the ln of something that's not x, so we have the ln of u, whether that is x squared or 5x minus 2 or whatever is inside of the ln, how we find that derivative is we write what we see. So what is inside the ln goes on the bottom of a fraction, and what goes on the top is the derivative of what we see. So this problem, you can either bring the 2 down in front, then take the derivative, or you can write what you see on the bottom, which is x squared, and on the top, you would put the derivative of that, which is 2x. And this could cancel out, so we have an x on the top, we have x squared on the bottom, so the derivative here is 2 over x. Looking at number 2, so we have the same thing, where we have the ln of something else. So to take the derivative of that, we write what we see on the bottom. So we see 5x plus 1. And then on the top is the derivative of what we see. So the derivative of 5x is 5, derivative of 1 is 0, so it's gone. And that's the derivative of number 2, and that's all you have to do. Okay. And number 3, we have another ln. So in this case too, you can either bring down the 3 in the front, or you can use the chain rule and take the derivative. In this case, whenever I have a power on what's on the inside of the ln, then what I do is I just bring down the 3 first. So I can rewrite this as 3 times the ln of 4x minus 1. So when I find this derivative, it's just 3 out front. And then when we take the derivative of an ln, we write what we see, 4x minus 1, on the bottom of a fraction, and we take the derivative and put that on the top. So then we can multiply the 3 and the 4, so our final answer is 12 over 4x minus 1. And that's our derivative. Now, if you didn't move the 3, you would still get the same derivative. Everything would cancel out and you'd be fine. So remember, you'll have one of these type of questions on the quiz.